Life cycle assessment, also called LCA, is a method of evaluating the environmental effects throughout a product's entire existence, examining each phase from the extraction of raw materials to manufacturing processes, consumer usage patterns, and final disposal methods. By examining each stage, LCA helps people understand how a product affects the environment over its entire lifespan. It provides insight into the hidden costs of production and consumption that, while not always visible in a product's price tag, contribute significantly to resource depletion and pollution. Human ability to see the larger picture through LCA allows for making informed decisions about design and consumption. A powerful example of life cycle assessment can be seen in the smartphone industry's supply chain. LCA reveals how the mining of rare earth minerals in various countries creates acid mine drainage and habitat destruction, while manufacturing processes in other nations consume massive amounts of water and energy. The global transportation network connecting these phases adds carbon emissions, and short device lifespans coupled with difficult-to-recycle designs create mountains of e-waste. By mapping these interconnected impacts across borders and ecosystems, LCA shows how the impact of the technological systems people use extend far beyond individual consumer choices, exposing the need for systemic changes in how products are designed, manufactured, used, and recovered. LCA connects closely with the broader realm of sustainable design, highlighting how materials and production methods can be optimized to minimize negative impacts. It also relates to environmental policies, as many laws now require companies to disclose the life cycle impacts of their products. Furthermore, with the increasing amount of electronic waste, LCA is a critical tool in information technology for designing more environmentally friendly devices and recycling processes. These connections demonstrate how LCA can inform and improve practices across different fields, leading to more thoughtful and informed approaches to meeting human needs while protecting natural systems. The life cycle assessment of agricultural irrigation systems illustrates their significance in comprehending both environmental and social effects. From manufacturing irrigation equipment to water extraction and distribution, each stage impacts ecosystems and communities. For example, large-scale irrigation projects often divert water from natural waterways, affecting downstream communities that rely on these sources for fishing, transportation, and cultural practices. This highlights how LCA not only addresses environmental impacts, but also underscores social contexts and consequences, offering a holistic approach to understanding the broader implications of technological systems within specific landscapes and communities. The application of life cycle assessment ties directly into the fields of conservation biology, cultural sustainability, and environmental fairness. In conservation biology, LCA informs how production processes might impact ecosystems and biodiversity, prompting the design of more sustainable practices. Cultural sustainability involves understanding how the life cycle of products affects traditional ways of life and cultural heritage, encouraging choices that reflect and respect cultural values. Environmental fairness utilizes LCA to spotlight and address the unequal environmental burdens borne by particular communities, promoting practices that protect both human and ecological health. These interconnected areas highlight the role LCA plays in broadening understanding and influencing positive changes across a range of fields.